Hello and welcome to my Let's Code series. This is a series of videos where I'm basically learning and coding at the same time as you're viewing this video. So it's not an instructional video, it's not a recorded live stream, it's more of a, you find a topic, you find something you're interested in, or rather I do, and then I learn it and build it on air, so to speak. So let's get into today's topic. Today I'm thinking of handling or of learning the web workers, and so I thought that would be an interesting project to start as a Let's Code session. So one thing I wanted to first look up is what a web worker really is. And I hear a lot about these workers. There's a web worker, a service worker, and I've heard a few different other terms used. Not that I can recall them right now, but let's see what MDN or what Mozilla tells us. So a web worker is a simple means for web content to run scripts in background threads. So what we're basically looking at is being able to in some way run our JavaScript without blocking the main thread. Now if you've used Electron or something like that before, that's, I feel like, a very straightforward thing to understand. As a front-end or back-end developer, I think you would have encountered something like this before. But yeah, so that's basically what we'll be doing with that. We'll be creating a web worker while just reading the docs, I guess. I think the Mozilla, the MDN docs, I don't even know what MDN stands for. Is that Mozilla like Developer Network, maybe? I don't know. Anyway, so what we're gonna do is build that. I think what we'll need for this is basically an indexed HTML file. I looked through the docs earlier, and we'll need two different JavaScript files, a main JavaScript file and like a worker JavaScript file. So I guess let's get to that. I'm gonna make a new directory. Let's call it worker test. I'm going to go ahead and zoom in a little bit. Right. Let's get in there. I'm going to make this into a Git repo so I can share it with you guys at the end of the video. And my microphone is right by my keyboard, so hopefully it's not an overpowering sound, but I like the clickety clacking of keyboards in videos, so that's why I'm kind of keeping it there. And let's make those three files. And why don't we go ahead and run this on a server? And I hope there is a quick, easy NPM or a node server that can watch for changes so they can reload. Let's see. Is that what? That's a lot of downloads. Let's see. HTTP server port. Is there like a watch mode? Would that be HTTP watch maybe? Alright, why don't we do this? No. So this one has everything we need. We would just have to refresh ourselves. Is there a watch function? That's my thing. Nothing about that. You know what? We're going to go ahead and use this one and deal with everything else later. So while we wait for that, let me open another shell. And we can start editing the files. I have quite a few different shells opened. we go. Oh, I must have messed up something. Alright, I'm gonna have to restart that shell. Oh, I guess I don't have to. Alright, let's go ahead and start editing it. I'm always loath to I can never remember the exact syntax for creating just a basic index of HTML. So I'm gonna go on CodePen and I'm gonna steal their basic HTML template. Alright, there we go, that's it. Doc type HTML. And title. And I'm actually going to do this. Alright, so we have an index.html. Now we just have to import the JavaScript file and we can get started. So there's that script source main.js. Alright, and we're probably gonna display all of the actions or everything that's happening through console log, so we're not gonna deal with UI or creating a like a div that displays messages. We're gonna look through the console at everything. Okay, so let's see what's going on here. Worker feature detection, that's great. So let's start with that. So the worker is attached to literally the window. So we'll do that. Cool. And then you spawn a worker. So let's do that. Let's do my worker. Now, if I understand this correctly, having this worker is like a good way of doing background computations. So I'm going to try to create like a simple, I don't know, a simple calculator of, what do you call it? The Fibonacci sequence, maybe. No, we'll see. I don't wanna get ahead of myself. So it looks like you'd create an on change, and this lets you know if the worker sends you. No, that's not. Okay. So sending messages is just worker.postMessage. So we can do my worker post message, and we're gonna make this kind of Redux or React. Not Redux, but yeah, Redux or Flux style. So we're gonna do an action. We'll do type hello, and then alright, we're gonna try this out. And what else do we do here? So this should send a message, and we can receive it on the other side using on message. So let's try to do that. So just this first line over here, I'm gonna zoom in a little bit. I'm gonna have to probably restart Vim. No, I don't. Okay. Yeah. So this first line over here that I highlighted basically spins up a new thread, and that thread is completely consumed by the worker.js. So that's pretty interesting. I thought that you'd be able to send code, kind of like, I don't know, like having a routine just saying, execute this on a separate thread, but instead you're actually running a completely separate JavaScript file, which it makes me wonder how it works with bundling, right? I thought it would be pretty cool if you could spin up a worker using the code that you already have rather than having to import a new file. But all right, let's see how all of this goes. So we have a post message, then in the worker we have a global on change that, or on message, which will capture our messages. This feels very awkward, this kind of format. Alright, so that should do it. Let's go ahead and use that HTTP server. Is it HTTP server? Oh, whoops. Alright, so port 8080. Nice. Uh-oh, that's not what I wanted. Huh. Why? What did I mess up on? Nice. Okay, that's the web worker one. Great. Message received. Message received. Okay, so we got a message received. Where's that data? Dot data would give us that actual action. That's fantastic. Current target. So let me go ahead and zoom in to all this. Let's do full screen here. So this is the message event that we get when a main thread contacts the worker. Bubbles, cancel. So it's an actual message, or sorry, it's an actual event. It even has current target. This looks just like an event you'd get if you did like a on click or on key up or anything like that. That's what it looks like to me. And the dedicated worker global scope is the source and the target. And I saw something here. We'll have to look into that. But basically what they're trying to say is that the worker operates on its own scope. Dedicated worker global scope. Okay. All right. And it looks like if you want to share the scope between several workers, there's a shared worker global scope, and I wonder how that works. Let's look into these real quick. So dedicated worker, I'm gonna zoom in because everybody needs a 1080p streaming just to be able to see this. So this is the scope of the worker, the global scope. So instead of window, we get this. And I read this earlier, but a window is inaccessible, so you can't actually do anything with the DOM, and you can manipulate the DOM, and you can manipulate a lot of other things. So it's accessible through the self keyword. That's interesting. I didn't know that was a reserved keyword. All right, so we have the name. That's fine. Self console associated with the worker. We're gonna look at that a little bit. Navigator, performance. Great. Event handler. We have an on message. So I guess you would do self.onMessage if you wanted to be a little bit cleaner. And there's an onMessage error. That's fine. We have closed. That looks like it's basically like I'm gonna terminate the thread from within the thread. And I saw here that there's a terminate function. So real quick, just so we can get a good handle on this. From the main thread, if I wanted to close or discard my new thread, or sorry, the worker, I could do my worker.terminate, and from that point on I can't send any messages, which that works. And from the worker you can actually do a close, just like that. Let me see if they have it here. Yeah, close. I kind of like the idea of doing, I don't like these like global namespaces. I like writing maybe self.onMessage would make more sense to me. Let's see if that works. Let's see if I understood it correctly. Whoops. Where am I at? There we go. Okay, so let's try this out. If it still works. I still get the message. That's fantastic. That's great. All right, so we can use the self keyword. Like I said, I kind of like the idea of not referencing these global functions or messages or whatever it is, and just namespacing it so I know what I'm referring to. That I'm referring to self. The same way I like to do window dot something, rather than just something, because that just feels feels dirty in some way. I don't know. It's not, these aren't properties of the language. That's what bothers me about it. They're properties of the context that we're in. So, all right. So we looked at the global scope, and we have self.console. It is its own console object. I guess if you do console.log, it still works because self is, yeah, all right. And then we have the shared worker global scope. Let's not worry about that right now. All right, and we can close out that pen. All right, let's see what else we can do here. So we can receive a message, right? Let's see. Yeah, there we are. So we can capture the message. That's great. And we can send one back. Oh, and then that on message hook is also on the worker object in the main thread as well. So let's write this real quick. So we can actually capture messages being sent back by doing this on message. And it should be the same message received thread. Okay, so now we're capturing the message on the main thread as well. So we almost have two-way communication. Why don't we? Okay, yeah, all right, and let's go ahead and send a message back. Whoa, what's going on? Okay, and we'll use post message. I got disillusioned with the self idea. Yeah, I know that took like no time at all. Type notification. By the way, you don't have to send this back, obviously. This is just me kind of thinking through how you could use this system. Message. Received message. All right. All right, cool. So what this should do is send some messages back and forth every time we reload. Let's go ahead and make this here. Let's put this on the side. Uh-oh, how come it's not working? Let me try to start it again in case it caches or something. No, it doesn't. Huh. We post that message and we're trying to receive it here. Great. All right, so we encountered the first problem. Post message worker result. That's fine. That's how we're using it. And on message, we do the whatever. Did I close the worker too early? Yeah. There we go. It's because I was closing the worker before I really got a chance to do anything. And restart. No. All right. I'm wondering if this is the server just kind of hiccuping. Or am I messing something up? I'm messing something up. I don't know what. Yeah, that's not all of our code. It's caching it, isn't it? What is it, like shift? Okay, empty cache on hard reload. And let's see if HTTP server has like an option for not caching. I'm not sure what happened there. What am I having issues with now? Waiting for cache. What do you mean waiting for cache? Alright. There we go. Alright, so we have communication across these. That's great. Is there anything else? Let's go ahead and no, I like this, but handling errors. I don't want to deal with errors right now. Import scripts. Worker threads have access to a global function. Import scripts, which lets them import scripts. That makes sense. So is this like an import as well? Okay. Any global object from each script. Maybe that'll make okay. So this sounds like it's like an almost like import, the import keyword. But maybe it's synchronous. Okay. Yeah. All right. Yeah. Okay. So what do we get? The situation we get into, because this is a worker, we can easily synchronously try to get something. So we can import all these files, and then we have access to our global namespace. That's nice. I don't think we're gonna use that. I don't think I want to check that out yet. No, I do. Let's see how that works. Let's create a new one. Let's do like a utils.js, and let's go ahead and import it in the worker. Utils.js. All right, and then let's call it utils, not util. I hope you all like the format of this. I'm just kind of dabbling and trying to find my way around. Utils is running. All right. We'll import scripts. We have this notification thing going on. Man, what is with this caching? Yeah, I'm gonna check out this if the HTTP server by chance does caching. Cache, set cache. All right, and we're gonna disable cache altogether. And now we have to do a hard reload again. Nice. Utils is running. Okay, utils runs before everything else. Message received, and message received on the main thread. Perfect. So we have two-way communication, and we're using utilities. Now, I think that pretty much like sums up how workers work. Then we can terminate them on either side whenever we want to. Why don't we try to do a simple project? Why don't we do a, let's see, why don't we run something like Redux through here? We're not going to use Redux, but we're going to use that kind of messaging system. So we're going to have type, we're going to do message. All right. And we're going to do payload. And we're going to create a function. Yeah, we're going to create a function called message worker. And that function is just going to send out this exact post message. It's going to update our state. And in the worker, we're going to just get rid of that. We know it's e.data, and we'll do a switch. Let's initialize a state. State, empty object, and we're going to say, let's see, switch e.data.type. Case message return byte not return. State equals object assign, you know, this whole thing. Data.message. And we'll do default. No default. Alright, and then we're gonna post message to state back. State. Perfect. And on the main thread, on listening in, we'll do a console log data. State. Let's see if this works. So my idea is to be able to access this message worker function from the console and test it out. Message undefined. Oh, whoops. Hey. Message undefined. Oh, it's payload. Alright. Nice. And so we should be able to do message worker. I like web workers. And this is our new state. I like web workers. This is nice. Cool. And so we could technically offload the entirety of Redux onto the web worker to do computations and figure out the state, and then just let us know when it's ready. I'm sure there's some middleware that exists that can do this for you. I'm kind of enjoying this session, so why don't we keep working on this? Why don't we keep hacking on this? Let's try to do some computations on the worker. What is that? Power of something? Math.pow? Is that what it is? Power. That's what it means. JavaScript. Let's look up the documentation on that. And it's X to Y. And so we're gonna do like a really crazy computation on the worker thread. Let's see if we can demonstrate how much it can slow down. So let's do a function how exponent, and we're gonna go ahead and first do it here. So math.how exponent, and we're gonna see what happens to our performance if we do things here. So how nice. So we'll do like 10 to the, or like 99 to the power of 125, and let's return it. I wonder what's a good way of looking at performance. Let's try to do this, right? Infinity. All right. Is there something less? This is too fast. I can't. This sucks. Well, it doesn't. But let's see if we can find a quick Fibonacci JavaScript solution. I've done these before. I just don't remember them, and I wanted to see. Yeah, this is perfect. This is absolutely perfect. Yeah. So let's try to do Fibonacci function fib. Oops. Oh, come on. There we go. I don't know why it indents by 4, but do I have, maybe I have prettier, and that could really solve things. Whoops. Oh, cool. This is the unoptimized version on top of it. The reason I say unoptimized is because it runs the Fibonacci function over and over. If you actually do a for loop, it's much more performant. So let's see what happens now. I think we're hitting like the half-an-hour mark right now. So I think this is going to be our last little project. So Fibonacci, we'll do 20. It's very fast. Okay. Okay. Is it not working at all? Can't press enter anymore. I think it's actually still computing these. It's unresponsive. Yeah, that's what's happening here. I can't select an element. Let's see if we can initialize the profiler. I think this is gonna crash the window here. Yeah, let's not do that. Okay, so the console is accessible, but everything, yeah, I can't do anything. It's stuck. Let's see the memory output of this. Yeah, it's taken up like 14-15% of my CPU. That's kind of crazy. I really wish that I was able to see into it. Yeah. Here's the real test. If you can close out the window. Yeah, there we go. All right, so it's definitely crashed, or it's hanging. Let's try while it's while it's trying to figure out what to do. Let's go ahead and rewrite this and send it into the worker and see what happens with that. So we're gonna post a message, and we're gonna do. Oops. Fib. Now, if I understand it correctly, fib should now be globally accessible here. So let's do case. My backspace is wrongly mapped, so that's why I'm running into issues here. Wow, it's taking up 20% of my CPU now. Alright. Object.assign state number. And we'll just say it's fib and e data payload dot. What did we send? Fibonacci. It's not a message. It's what would it be? Number, I guess. Payload dot amount or sequence. Sequence. And let's do that. So I had to step away for a little while and good maybe 20 minutes, and it's still not working. Yep, it's still locked up. All right, let's see how well this one works. Sequence. And all right. One thing I also want to test with this is if this on message is synchronous or asynchronous, or rather if the messages are answered in order or not. So let's see if we can do that. I really wish I could close down this tab because I don't really care about it running anymore. Oh, this is running. I forgot. Let's set a message to index.html so I know it's loaded. Hello. Damn it. There we go. All right. Fibonacci is not defined. It tells. Oh, that was not bad. I'm a bit confused. I haven't sent a message yet. So why is it trying to figure it out? This is really confusing. I don't get it. What? This is weird. Why would it run the Fibonacci function from the start? What if I comment this out? Does this still make a difference? But there's nothing calling it, right? Oh, well, this is my fault. I forgot a break. All right, so it's a Fibonacci 1. Why is that an issue? Damn it, I keep doing that. Alright. Maybe I wrote the Fibonacci function wrong. Fibonacci 1. Missing. Oh, okay. State undefined. Why would it have a message that's undefined? What did I mess up? Does the state get reset every single time? Shouldn't, right? No, it doesn't get undefined. All right. So what did I mess up? What did I mess up? Fib. Okay, maybe it's the action name. Yeah, there we go. And all right. Fib. There we go. That was the problem all along. All right. So if I do this, number 1, let's do 10. Okay, that's pretty fast. 30. That's pretty fast. The other one, I think I did 200, and then it freaked out. So let's do 200. And it's okay, and it's running. But our main thread, everything is accessible here. I should be able to even do things like, oh yeah, let me see if I can message the worker. Hi. No, the messages are kept in queue. Perfect. Now, the only problem is this might take a while. And it's that thread is consuming all the right amount of CPU. All right, let's go ahead and I'm gonna end these. I'm gonna crash these intentionally. And let's crash this one as well. All right. We're gonna reload this one. All right, so let's do a Fibonacci that still takes a while, but doesn't take that long. So we know that 30 is pretty fast. 40? 40 takes a little while, so we're gonna do this, and we're gonna do message, worker, test, and we'll see what happens. Yeah? Alright, so it happens in order. That's great. So I think this would be it for the video. I'm not gonna do any more. But as you can see, you know, workers are pretty easy to create. You just have to register them. Once you register them, you can register I guess a listener is the best way to put it. A listener for messages from the worker. And then we can send messages to the worker pretty easily. And I think that this actually lends itself to a really great format. You know, if you send messages back and forth in this kind of Redux or Flux style object messaging, then you know I think you can have a pretty good architecture with that. You can also use any other type of messaging or any other conventions that work for you. I know that for my Electron apps, I built like somewhat like an HTTP kind of a thing, where instead of type, it would have like a route. Oops. And you know, it would be something like, oh, fib, and I don't know, or I don't have a good example, but it definitely shows that you know you can work with the main thread and the UI as stuff is getting computed on the back end, on the worker rather. What's great is that my takeaways are that what's great about web workers, like here's my takeaway of that. I don't know why I'm having trouble speaking today, but this is nothing new. My takeaway is that you can push off calculations that will lock up the thread, and we saw in the other one, you know, it was just locked up and you can't access anything, you can't do anything, you can't run any code anymore. Using a web worker means that you can, you know, do all this work on a separate thread and still be able to interact with the UI. I have a task manager open in a separate on a separate monitor, and the CPU usage was basically exactly the same between that non-web worker computation and the web worker computation. So you know you're not saving yourself any cycles or anything, but you're able to do some really nifty things here. The other takeaway is that the messages that you send to the worker come in order and execute in order. So you don't have a situation where you send in one and you send in a different message and they're asynchronously computed. You know, so this is actually great for like these things that I'm talking about, like Redux style stuff. You know, you could technically, you know, even with this architecture, you can already see that this lends itself really well to Redux, how Redux works. And we'd be able to just, you know, compute a new state and send that back. And perhaps, you know, to hook it into Redux, we would somehow be able to dispatch, you know, wrap Redux and dispatch an action into it that would just replace whatever state there is with this new computed state. I'm a huge fan of that. Another thing that I'm a huge fan of is this import scripts. That's very similar to import syntax, except this is done synchronously, and it just dumps whatever file you have here into the, you know, quote-unquote global namespace of the worker. This is very different from, you know, from CommonJS or whatever that syntax is called. Style where you do var something equals require utils, right? It's different from imports. None of that, you know, these dump the file and whatever is exported into a variable. Here we're really just dumping it into that, what was it, the global worker namespace. I'd love to look at shared workers, but I think this has run for quite a while. Yeah, I don't really know what to do with that. Yeah, so I would have to look at that. But anyway, so this is pretty much it. I hope you enjoyed the video. I have way more videos on YouTube, and some of them are kind of like this, some of them are not. I really like this style of learning and of making videos where I learn along the way with everybody else. I did do a little bit of upfront research just so I wouldn't be too lost, and just so I'd know, you know, the scope of what I would have to create, and that's fine. And yeah, I hope to make more of these videos, and I hope you enjoyed it and understand workers a little bit better, because I know I do.